So we ended class talking about fractions, linear equations with fractions. We're going to go into kind of step that up, but use those same ideas to talk about rational equations. So just finishing off this section. If you remember when we said we ended with a problem similar to this, we're solving equations with fractions. I gave you a couple of different methods, but the one we're going to really want to focus on is multiplying by the least common denominator. So just a reminder, we did this problem in class, but the least common denominator was 12 here. So I said, okay, multiply every single term here by that least common denominator. If we do that, the idea here is that we can do a lot of canceling and get rid of these fractions. So for instance, for this first term, if we multiply by 12, we can cancel, remember numerator and denominator, if you see terms that can cancel, so 12 and 4 can cancel, or factors that can cancel, you can do that. We're left with 3. For the second term, 12 times x minus 1 over 3. Both are divisible by 3, so you're left with 4. And then 12 times 2 gives you 24. If you write what's left, so 3 parentheses x plus 2 minus, notice we have that minus sign up at the top here, minus, and then from our second term here we have 4 parentheses x minus 1 equals, and 2 times 12 gave us 24. We turn it into a problem that's a lot easier to solve because we don't have those fractions involved anymore. I know you could have done it in, we gave 2 different ways you could solve this, but just keeping in mind this method of multiplying by the least common denominator is really going to help us when we get to harder problems. Harder problems being things like this. What if our denominators have variables in them? Variables, expressions, things like that. We can still use this method of multiplying by the least common denominator. So step 1 is figure out what the least common denominator is. So I see 5 and 2 in my denominators, so I know that as far as the common portion, the number portion, 10 is going to have to be part of my common denominator. And then the other factor I see x's. I want to pick, to figure out my least common denominator, I want to see the maximum number of times in a denominator I see that factor. And so what that means is I have 1x here, I have 1x here, I have no x's here. The maximum number of times that the x appears is just once. My least common denominator is going to be 10x. Step 2, if I multiply everything by that least common denominator, it's going to allow me to do that canceling. So I want to multiply by 10x, by 10x, by 10x. If I do that, I'm looking to cancel in each term. 10x times 1 over x, 10x times 1 over 5, and 10x times 3 over 2x. If I do this, if I multiply by the least common denominator, I'm going to get rid of all of those fractions. I'll turn them into a nicer linear equation. So if I look at my first term, I can cancel x, numerator and denominator, and I would just be left with 10. That was next to the equal sign. If I look at my second term, 10 and 5 cancel. Both can be divided by 5. I would be left with 2x. 2x times 1 is just 2x. And if I look at my last term, 10 and 2x, both can be divided by 2. So I'd be left with 5. Oh, I forgot my x. And cancel out my x's as well. I shouldn't be left with anything in the denominator. 10x and 2x cancel, becomes 5. 5 times 3, and I bring down that plus sign, plus 15. I've turned it into a much easier problem, multiplying by the least common denominator, and then canceling out each term. Turns it into a much nicer problem. This is now a 2-step equation. Subtract 15 from both sides. Negative 5 equals 2x. Divide by 2, so x has to be negative 2.5. It makes it into a much easier problem. So let me do one more as an example for you, and then I'm going to leave you with one problem to try on your own if you could prepare it for tomorrow. But this is our last example here. You notice my denominator is x plus 6, x minus 2, and then I have this quadratic. So I'm looking for what factors, what would make my least common denominator. From last chapter, if we're going to do least common denominator, we have to factor. So what multiplies to be negative 12, adds to be positive 4, well, that would be plus 6 and minus 2. My least common denominator, the maximum number of times factors appear. Well, x plus 6 appears once in this fraction on the right, once in this fraction on the left, so the most it appears is once. And same thing with x minus 2 appears once here, and once here. So x plus 6, x minus 2 would be my least common denominator. So this one becomes a little more tricky. We're going to multiply in every spot by my least common denominator. It looks trickier, but it maybe doesn't end up that way. So I want to multiply x plus 6, x minus 2, that least common denominator, times my first term, 3 over x plus 6. I want to multiply my second term here, x plus 6, x minus 2, times 1 over x minus 2. And my third term here, 4 over x plus 2, x minus 2, x plus 6. Multiply that by my least common denominator, x plus 6, x minus 2. The easier thing here is the canceling. If I start on the left side, x plus 6 appears in numerator and denominator, just like last chapter, you could cancel those out. So this becomes 3 times x minus 2, which is 3x minus 6. Bring down the plus sign. X minus 2 in my second term cancels out. So I'm left with x plus 6 times 1, which is x plus 6. Bring down my equal sign in between. And if you notice in this last term, x minus 2 cancels out, and so does x plus 6. So all I'm left with is 4. It makes this ugly problem to start out with look much nicer. Combine like terms, 4x, negative 6 and positive 6 makes 0. So x has to be multiply by the least common denominator. Find your least common denominator and multiply all of your terms by it. Canceling, once you get some practice in it, will end up being pretty simple. This is a pretty hard example as far as so the problem I'm leaving you with is not as difficult. Remember, when you're finding your least common denominator, 3 is a factor and x minus 2 are factors. That whole expression is a factor. So when I'm saying my least common denominator, I have to include the 3 in any denominators I make, and I also have to include one instance of x minus 2. So your least common denominator is 3 times x minus 2. Try and finish the rest of this problem off. We'll talk about this first thing tomorrow.